Good evening, guys. Welcome to ML Ticket, and we are in a ongoing project where we are addressing a regression problem about housing census. We have taken a dataset from 1990 California housing census, and we are trying to predict the median house value. Okay, so today's session is about categorical variables and categorical features. Or okay, so this is a very common scaling, feature scaling. I would not say feature scaling. This is a very common attribute for you to change. Okay, during the data pre-processing, this is a very common thing to do. Almost every dataset that you come across will have some kind of categorical values. Okay, so let me just present my screen and let's get started with it, because we have a lot to do. And today I'm going to explain you it in a very elaborate manner. Okay, and with extensive examples so that you can understand every little bit of it. Okay, so categorical values. Now, why we need to pre-process the categorical values? We need to understand. I am always emphasizing on the point that the code is not important. The knowledge behind the code is the main important. Okay, is of the utmost importance. Okay, so we need to understand that why we are doing it. So why we are transforming these categorical values? As we have seen, the categorical values are nothing but these values are string values as such. If I go to the very top, you can see this ocean proximity attribute, which contains some kind of string values. Okay, and we later checked and found yes, it does contain some kind of string values, and it is not in float or int or double. So we need to tackle that, and these types of values are all known as categorical values. Okay, so this is a very, as I said before, this is a very common transformation to do, and very frequent, to be honest. And almost every data set that you come across will have some kind of categorical values, and you need to transform them. So we need to understand what are these things, categorical values. Why we need to transform them? Let's see. If suddenly I start speaking in Klingon or Abidabi, Abidabi is a language uh, which you can see in the Big Bang Theory. If you are familiar with the TV series, you won't be able to understand, right? So if I start speaking to you in a foreign language other than English, or I start speaking in my native language, you won't be able to understand. Some of you may, but most of you won't be able to understand. So this causes problem. This causes some kind of communication problem. Whatever information that I am trying to give you, whatever things that I am trying to teach you, you won't be able to comprehend 100% of it, because you won't be understanding the language. Okay, the medium, you cannot get the medium. When you can't get the medium, you cannot understand. Okay, so similarly, our child or the model is comfortable with numbers and not with strings, so why bother him? So, as we know that the machine learning models love numbers, they like to play with numbers, whether it's a decimal number or a binary number, but they are always in love with numbers. So they are not very good with strings, at least at this point, at the very beginner level that we are talking about. These machine learning algorithms are not very good with numbers. So why should we supply them numbers? We should not be giving numbers as input, sorry, its string values as input, because it will cause problem later. So we need to change those string values in some kind of numbers so that our model can understand it. So now we have to think of some kind of method to transform those string values into some kind of number so that our model can easily comprehend or easily understand or easily learn. Okay, so the thing is that how do we do that? Okay, so let me get to a little bit of depth, though you don't need it at such a point, but still you need to understand. There are types of categorical values. Okay, there are various types of categorical values, but mostly there are two types. So I'm going to talk about those. One is known as nominal encoding. If you look up in the internet, these categorical values, you will find it can be divided into two parts, and roughly it can be divided into two parts. That is nominal encoding and ordinal encoding. So let me just start with nominal encoding. What is this? So numerical data, as the name suggests, involve features that are only composed of numbers such as integers or floating points. That's quite obvious, I guess. So let's take an example. A place variable. Suppose there is a variable place with the values first, second, and third. Okay, this place variable above does have a natural ordering value. This type of categorical variable are called an ordinal variable because the values can be ordered in some kind of rank. Okay, so as you can see that the first, second, third, we can we can have a one-to-one corresponding relationship with the strings and the numbers. Like we can assign 1 to first, 2 to second, 3 to third. So it has a natural ordering. Okay, that's why these values are also known as ordinal variables. These type of categorical values are also known as ordinal variables. So um, you can just read through it. I'm just going to read through this information. A numerical variable can be converted into ordinal variable by dividing the range of the numerical variable into bins and assigning the values to each bin. For example, মানে stay focused when I try to understand the example so that you can understand that definition. For example, a numerical value between 1 and 10 can be divided into an ordinal variable with 5 labels with a relationship 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is called discretization. Okay, so these are some of the mathematical approaches to what we are trying to achieve right now. So it is telling that naturally, if there is some kind of ordering, it is known as ordinal encoding. Okay, so what is this nominal encoding? I have defined a nominal ordinal encoding under nominal encoding in such a type. Okay, so nominal encoding is basically the first bullet point, the numerical data. Nominal encoding means that the data is numerical in nature. So if we have numerical data which is only composed of numbers or integers or floating points, then the data is nominal. But other than that, we need to care about the ordinal encoding. So ordinal encoding, it is a unique category values. It is assigned to as an integer value. For example, red can be assigned to 1, green can be assigned to 2, blue can be assigned to 3. This is called ordinal encoding or an integer encoding as it is easily reversible. Often integer values starting at 0 are used. For some variables, ordinal encoding may be enough. Ordinal encoding may be enough. The integer values have a natural ordered relationship between each other, and the machine learning algorithms may be able to understand and harness that relationship. Okay, so this is it. So basically, what we are these are I'm just going into a depth right now. Just you don't have to understand everything that I'm writing right now, because this is a little bit above the beginner level, but still I'm just introducing you to the concept. So basically what we are telling is the bottom line is we have to find a way so that we can represent these string values with some kind of number, because our machine learning model won't be able to comprehend or understand these string values. So we have a lot to do. So let's get started with the code. Okay, we have a lot to do today. So sorry. So as array is like just like an array. Oh, okay, it's just a fancy name that NumPy gave to it. So to do ordinal encoding, our sklearn provides us with a library. Of course, it does. Now, why would I bother to write everything other than that? That is known as ordinal encoder. So I am going to show you that what it actually does, so that you can have a clear understanding that what it is doing. If I show you the bigger picture right now, you won't be able to understand, or maybe you may not understand. So I'm going to show you a very small scale the picture. Okay, so I am going to create an array. Okay, as array is just like an array. Okay, I am going to create a 2D array. Okay, um, it contains some random colors, I guess. So red, blue, and let's say green. Okay, green. Okay, so we have a 2D array where the first row contains red, second row blue, third row green. Okay, so let me just print the data. Okay, so we are sure we can just you can just see that this is nothing complicated. It's just an 2D array. So let me just get instance of this ordinal encoder. Let me just spell it right. Okay, I'm creating an instance. I'm passing no parameters. Okay, I'm taking a variable called result, and I'm going to fit and transform. Remember yesterday we talked about fit and transform. For that, when we fit the data, then actually it provides a staging area, and when we apply the transform method, it actually transforms the data. So apparently almost every class that we use in sklearn comes with a fit function, transform function, and another thing, that is fit and transform. Okay, we will be talking about it in the next session when we'll be doing custom transformations, and you can see how it actually works. From the very base level, you will understand how it works. So still now, just understand this: the fit and transform method transforms the data, or does the what the class actually wants to do. Okay, so I have the encoder class. I have instantiated the encoder variable with ordinal encoder. So let me just take the encoder variable, and I'm going to apply fit and transform. Fit and transform. If you're having trouble with this fit and transform, I can suggest you to read some articles over the internet if you have still have troubles, because at this point, if I start explaining fit and transform, so the my flow will be disrupted, and I have to sit with you with this fit and transform for the whole session. So just don't get too excited. So I'm just applying the fit and transform, or the encoder, over the data, and let me see what output it gives me. So let me just print the result variable. Okay, encoder. Okay, spelling error, typo. Okay, what do we have here? It is encoding the results, and it is providing some kind of number, random number 201. Okay, so what is this 201? Now it is actually saying that it has assigned red to 2, red to number 2, blue to 0, 1 to green. Now you may argue, no, how can I believe you that the red is assigned to 2? If it is not, if I say, if I change the data, okay, if I just change data and add another row which is named as red only. Okay, so what do you think it happens? If red is assigned to 2, it will always generate 2 when when it sees red. Okay, so it should output 201, then 2. Okay, so let's see what happens. Okay, we can see that we have a similar thing. So we can be rest assured that this encoder, what it is doing, it is actually linking up one to one corresponding relationship with the string values. Now notice that if I capitalize the R in the sorry, R in the red, it will give me a different kind of encoding. Look, it is considering this red as a different red from this red. Okay, we it has to be the same red so that it can encode it in a same similar way. So as we increase the number of increase the number of rows, it will increase the number of integers. Okay, so it won't stop. Okay, so this is what is known as ordinal encoding. Okay, you may think, Jay, yes, we have solved the problem, right? We have successfully transformed uh, string values into a number. Then, okay, we are done, right? But no, it is not that easy. It is not that easy. Apparently, our some of our machine learning data, you will I will be explaining this in the next session, when we will start feature scaling. You will understand it better there, but just hear me out here for a minute. Just mark my words, okay? J, some of our machine learning data algorithms, some of our machine learning algorithms do not like integer values. It only likes values between 0 and 1. Okay, so if our machine learning algorithms likes values between 0 and 1, then we have a problem, because if I create 100 or 1000 categories, it will generate an integer of 1000 numbers, and our algorithm won't be very comfortable with this. So we have to find a way to generate a binary kind of number like 0 1 and all. Okay, so that our so that our machine learning algorithm can quickly absorb the information. Okay, so what how do we do that? Apparently we have a class for this also, and that's very funny, I guess, because apparently everything that you want, sklan has already provided it. Okay, whether you want it or not, whether you are doing it or not, but sklearning is just providing it. So I am just going to copy the whole cell, because much of the code is same. Just I am going to change some of it. So I am not using ordinal encoder, because we have seen what ordinal encoder does. We are using what is known as one hot encoder. Okay, from pre-processing only, and everything is true. And okay, sorry. Let's just copy the encoder, then paste here. I am going to pass pass a parameter called sparse equals to false. By default it is true, that's why I'm doing this. So I guess everything is correct. Hope that it works. Okay, let's see. Oh my god, we have got some 0 and 1 numbers. If you can see that now we have a 0 1 and our strings are now the strings have been converted or transformed into zeros and ones. That are that the first row contains our first row contains 0 0 1, next row contains 1 0 0, next row contains 0 1 0. Similarly, as we have seen above, J, that the red is assigned to 2, and anywhere that red occurs, it will be transformed into 2 only. Similarly, since red here is assigned to 0 0 1, anywhere if red occurs, it will always generate 0 0 1. It is a very important thing to note, to be honest. So you may ask, J, why we are doing this. Just hold on for a little bit, because at this moment you won't be able to understand, because uh, you don't you have not learned feature scaling. That's why, because in the next session I'll be explaining you this in a complete manner so that you will understand. Just hear me out once. That is, if some of our machine learning algorithms like this kind of input, like zeros and ones, okay, only zeros and ones, they work better sometimes. Not all of the times, not all the times, but sometimes they do work better. And most of the times, it is better to do these things in zeros and ones, because it's a universal thing that computers like zeros and ones. You know that binary digits and all. So till that it was fine. Till date it was fine. Okay. Now, if I can draw your attention to one point, then you will understand. Uh, if I drop out in this output, if I drop one column, there are three columns, right? If I drop any one of those columns, will it affect our output? Do we have a problem with that? Will it generate any kind of error or some kind of overlap? Okay, if you just delete the last row, last column, okay, this 1 0 0 1, only this row. Just imagine the output without this last column. If you imagine the output without this last column, then you will see it won't make a difference. You will still have a unique identifying 0 1 combination for every string. This is a particular problem in one hot encoding, but this can be tackled by just dropping one of those columns. Apparently, it is this theory is so famous that one hot encoding, it also comes with a attribute attribute which makes our lives easier. Of course it does. In the one hot encoding, I can just pass drop equals to first. I'm going to drop the first column. Okay, so it will drop this 0 1 0 0. Okay, so let's see. And voila, we have it. So we have dropped a column. It does not make any difference. We still can identify things. Now I need to tell you some of the things. Now you have to understand clearly the distinction between these three cells, because you may argue, Jay, okay, these three cells are almost similar, right? These three cells does exactly same things. They transform the data, integer data, sorry, string data into integer data, so that our machine learning algorithms can understand it well. Yes, it does, but you have to understand the distinction between them. Ordinal encoding converts the data into integers, okay, or whole numbers, I would say. Okay, it will convert the data into whole numbers from 0 to infinite. Okay, if you increase the number of instances inside the data set, as we have only three instances here. Why I'm going only saying three? Because red, blue and green are the only unique instances. Red is repeating. Okay, we have three instances in this particular data set, and that's why it is generating three unique whole numbers, that is 0 1 and 2. If there are thousands of instances, it will generate thousands of unique numbers. First thing, what does one hot encoding do? One hot encoding does the same thing, but it converts the data into a binary format, or rather I would say it converts the data, our string data, into a distinct combination of zeros and ones. Okay, see, in the similar way as ordinal encoding, one hot encoding also ensures that the number of instances, the as the number of instances increases, the number of unique combinations also increases. Okay, because I don't know if you can understand it or not, because why we have, you may argue that if we can just drop one column and still have the unique combination, then why doesn't it drop it in the first time? No, no. It should drop it in the first instance only, right? When we are doing one hot encoding, it should drop it, right? Why it is not dropping it? You have to understand this thing. If you argue in that case, that I have to go get a little bit deeper, though you need not understand this thing completely, but I'm still telling you that there are three instances, right? Okay, if there are three instances in digital electronics, and um, also in computers, computer engineering, or in mathematics also, if we draw a truth table with three unique variables, then it will generate eight numbers. Okay, that is 2 to the power 3, eight numbers. Okay, so with these three instances, we can generate eight unique combinations of zeros and ones. Okay, that's why we have three here, three instances. That's why three columns. Okay, if we now increase the number of instances, maybe it may increase. You don't have to get into a very depth of it, just you have to understand one thing. You have to understand one thing, just forget all those truth table and all. Just remember one thing: the one hot encoding transforms the string data into a unique combination of zeros and ones. And if you drop one of the columns from the output, it won't cause any kind of error. Okay, this is the first thing that you have to understand. Now, what is this one hot encoding uh, dropping the first column? This particular one hot encoding with the first column dropped is also known as dummy encoding. Okay, it is also known as in the machine learning community as dummy encoding. Okay, so we are dummy encoding the data here. But why we are doing this? It, you may ask, it is only one column, right? Why we bother to delete it? Because if we are working with 4 million data points, I am talking about a huge scale data set. If I are using a 4 million data points data set, then it will, that single column will generate, so it will consume so much space that you can't even imagine. Okay, and it will make our process slow, execution slow, everything, because it is outputting something which is not required, right? So it will take up space and time also, so we don't want that. So these are the things that you understand. Now we are going to do these things into our data set. So remember, we have column ocean proximity with this. So I am going to first separate this particular column. Okay, remember head, it prints the first five rows. Oh, sorry. Okay, so we have it. Wait, it's not printing the rows, right? Oh, sorry. Yeah, there we have it. Okay, so let me just use ordinal encoding once. Remember that I am not importing it once again, because it is already imported in the previous cell. This is just I'm just creating an instance and applying those changes into the housing cat, and I'm printing the first five values, right? Okay, so there we have it. You can see the ocean is appearing twice here. Okay, so that's why ocean is assigned to 0. The next instance is also ocean, that is also 0. And the fifth instance is also ocean, that's why it is also 0. So yeah, we have it. So all our data has been encoded. So if we want to see the categories that what it is encoding to, we have a function inside ordinal encoder, which is known as categories, categories underscore. They just output the number of categories that yet it is actually encoding. Okay. Okay. Now let's try one hot encoding. Okay. Acha, by default, as we have seen, J, it gives you a parse matrix. Okay, so what is this parse matrix? Sparse matrix, I would like you to Google and find out yourself, because I don't want to explain sparse matrix here. It will be a too long thing. Okay, so just Google as sparse. What is sparse matrix? It is nothing great. You will just understand right away. So by default, if we are not passing any kind of attributes, it generates a sparse matrix. To convert it into the so that we can see it, we want to see this matrix, right? So we can use numpy's to array, sorry, pandas to array, to convert the sparse matrix into array, and it will print it. As you can see, similarly, it is just generating a unique combination of ones and zeros to help us, and we can achieve the similar thing. To be honest, we can achieve this similar thing rather than doing this one hot inco housing cat one hot dot to array. We can just do one thing, that is copy this line, paste here, and pass a attribute sparse equals to false. Then it generates the matrix only. Okay, so we have it. Similarly, if we want to look at the categories, it also provides with the with the with the function which says categories. I think it says categories, right? Cat sorry. Oh, sorry. We have to take the encoder. Yeah. So there we have it, right? So this is the end of this is the end of your categorical values transformation. I have told you almost everything that you will come across. Of course, there are more advanced ways to do these things. There are so many uh, things, so many libraries that you can use. Previously, in a previous version of what do you say, scikit-learn, they used to use a library known as label encoder or labelizer, something like that. Okay, it used to do the same task, but it used to take up a lot of memory, and we had to code a little bit more. But in this case, by using one hot encoder, um, we reduce the number of lines. Okay, our main objective is to reduce the number of lines. Of course, you can argue that, oh my god, you have 74 cells right here, and now you are saying about reducing the number of lines. Of course, but because I am explaining every each and every possibility to you, because when you are doing your project, you won't be applying everything that I am writing here. You will be only applying the things that you need. Okay, the things that you think is important, because I am telling you, I am explaining this to you in a very very elaborate manner. Of course, I can you can say that there are other ways to do this thing. To be honest, transforming categorical values is a very very wide sector of pre-processing. Okay, if you are a data scientist, then it is a very big chunk of science contains with this categorical values transformation. So I have just shown you the tip of the iceberg, but whatever I have shown you is more than enough for you to go and start playing with it. But I would like to point out one thing, that I am not doing anything on the I am not changing anything on the data set. Okay, because if we look at it, our housing data, it is completely intact. I have not changed a single thing. Now you may argue, then what are we doing from the last few sessions? We are changing so many things, but why it is not reflecting? Because to be honest, I have not reflected those changes in here. Okay, it is not time for us to reflect those changes. We have to learn a few more things, then we can reflect those changes. So this is it for today, and this is everything that I want to tell you about categorical values. There are more things that you can learn, but this thing is enough to keep you going. And this is far more. This is better for most of the data sets or uh, datasets that you will come across from Kaggle and others, websites and all. So uh, so that's it. If you have any questions, please do ask me. Okay, I don't see anybody here, of course.